Hello, Senior 2. How are you? I hope that you are fine. Today, we're going to start our first lesson about the evaluation of the concepts of the atomic structure. As you know that the atomic structure has many developments through different ages. So it goes through different steps or different procedures until we reach to the final model of the atomic structure. The first one that to try to model or give an idea about the atom was Democritus. So Democritus, he imagined that the possibility of dividing any piece of matter into smaller particles or small particles, and this parts until we reach to the smallest part or indestructible part of it, which is called the atom. So in the atom, it's the smallest part of the any matter that cannot be destroyed anymore, or it's not cannot be divided anymore. And it's invisible. It's what? Invisible. So what's meant by the atom? The atom in the Greek language means a means no, and tom means divided. So it consists from two parts, atom, no, tom divided. So the word atom is in Greek means not divided. And it's the smallest part of any matter, cannot be divided into smaller particles. This is the idea of the Democritus. He was one of the greatest Greek philosophers, by the way. And then we come to the 4th century Aristotle. What Aristotle think? Aristotle thought that the matter composed from 4 things: fire, water, air, and dust. And if you mix them together, you're gonna get different structure for different matter, or you can change the cheap metals into precious one. So he started to mix the fire and water and dust and air with different proportional to get a precious metal. And of course, it's not a logical idea. It blocked the development of the structure of the atom for ages and for ages, because all the scientists were busy to try to change the cheap metals into precious one. And it's not correct at all. And then comes the scientist Boyle. Boyle ideas was in 1661. He is a scientist, or he was a scientist that rejected the idea of Aristotle about the nature of the matter or the substance that is composed from fire, dust, air, and water. And he tries to identify what's meant by the element, which is the purest, simplest form of the matter. Cannot get any simpler substance of it by any traditional chemical methods. So the matter consists from small things. As Boyle said, it's called element, and this element represents, or the word element represents the pure, simple substance of the matter, and it cannot be changed into simpler thing. So we have different types of elements. We have aluminium, we have iron, we have copper, we have gold, we have silver. So if you get a matter of silver, if you divide it into smaller and smaller and smaller, you will not get any more except this element, silver. If you get iron, so if you divide it into simple substance, you will get only gold or iron as it is. You will not get anything different. The element is the purest substance in the matter. And then comes to Dalton. Dalton idea about the atom was developed. Dalton idea about the atoms was developed in 1803. He postulated that the element composed from very minute particles, these very minute particles called the atom. So the element, as I told you, in the element that is the purest form of the matter, you cannot get anything purer than the element, and all the atoms in the elements, or this element is composed from smaller things or smaller particles, it's called the atom. And because you are in the same element, you're gonna find this the element formed from same atoms. What's meant by this? Suppose that you have, as I told you, you have a matter of gold. We have gold, which the symbol of gold is AU, okay? So this is called the matter of gold, and it's the element of gold. All the gold consists from smaller particles. It's called the atom. This represents the element gold and the matter gold. The smallest particle or the smallest part of the element, it's called an atom. So it's the building unit of the element, or the building unit of the its element gold. It's the smallest building unit, or the building unit of the element gold. It's the atom. And as you see here, that all the atoms in elements are similar. Nothing else except gold. Nothing else except gold. And they represent a very solid part. So this atom, it's like the very solid part. Masses of the atom of the same elements are similar because but they are different from element to the other. So if you ask about the mass of the gold, of course, this atom has the same mass of this atom, had the same mass of this atom, had the same mass of this atom. While if you get an iron element, which is formed from smaller parts, which is called the iron atom, the iron atom, the iron atom, the iron atom. These iron atoms are similar in mass, but they are different in mass from the gold. So each element consists from smaller parts. It's called the atom, which is the building unit of the matter. And these atoms, similar in everything. They are similar in mass. They are similar in the atomic number. They are similar in everything, while they are different from one element to the other. As I told you that the mass of the gold is different from the mass of the iron, okay? Then the compounds are formed due to the combination of the atoms in a simplest numerical ratio. What's meant by this? The most common compound that you know is water. You know that the water formed from 2 hydrogen to 1 oxygen atom. So could we write this water with a percent H4O2? No, of course, because we have a definite composition for the water, and it's formed from the simplest ratio. This is the simplest ratio. What is the ratio between the hydrogen and oxygen in the water molecules? It's 2 to 1. We couldn't write it as 4 to 2, although they have the same ratio, because each compound formed from combination between 2 or more elements, and they are different. Hydrogen is different from oxygen, and they are formed together or combined together in a simplest ratio with a definite proportional. You couldn't change the ratio of this element to form the water. Although H4O2 had the same ratio with the H2O, but it's different. We couldn't write the water in this form because, as I told you, that Dalton said, one of the postulates of the Dalton theory, that the compound formed from different elements with simplest ratio. Different element with what? With simplest ratio. Okay. Then this is the last postulate known as the law of constant proportional. So what's meant by the law of constant proportional? It states that each compound formed from elements, and they have contains the same elements in the same proportion, but the mass of them goes through the simplest ratio, as I told you. So how about the next scientist? The next scientist was Tomtom Model, or the Thomson. He was one of the greatest scientists that carried an experiment to discover what we call the cathode tube. What is the cathode tube? Here is the cathode tube, as you see. So the cathode tube, it's a tube, vacuum tube, contains nothing. It's vacuum pump, but it has 2 electrodes, the cathode pole and the anode pole. Cathode represents the negative, it made from a metal, and the anode represents the positive, and they are connected from outside with a very high voltage. This high voltage almost equal 10,000 volt. Okay, when the volt reach to the 10,000 volt, the cathode start to give a kind of rays. What this rays represents? It represents the ray of electrons. This is called the cathode ray because it emits from the cathode, the negative part inside it, and then goes to the anode and hits. Whenever they start to move, they hit the internal part of the tube and start to flash, making a fluorescent glow. So what is the cathode ray formed from? It's composed of electrons, and they are moving, as you see, in a straight line. They carry negative charge. So the cathode ray, it's the rays comes or emits from the cathode in the vacuum tube. If the potential difference between these two sides or these two poles of the tube reaches to 10,000 volts, a kind of invisible rays start to emit from the cathode and goes to the anode. How come they are invisible but we see it? We see them because they make a glow whenever they hit the tubes or the wall, the inner wall of the tube. The cathode tube properties, as I told you, they formed of very fine negatively charged particles, which is called the electrons, and the mass of the electrons are negligible, no mass for the electrons, and they move in a straight line, start to emit from the cathode, goes to the anode. Due to they are negative, so they are attracted to the anode, which is carry positive charge, and they move in a straight line. السبيد بتاعتهم less than the speed of the light, which is 3 × 10⁸. Okay, they have thermal effect. So whenever they heat, they have thermal effect, heat effect, and they affected by the metal plates, or they affected by the electric and magnetic field. They don't vary with the nature of the cathode material. So if we substitute this metal with other one, or we put it any other material, so the cathode will emit also this type of electrons with the same properties. So if you change the cathode material, the cathode rays or the electron doesn't differ. They are the same. And according to this experiment, Thomson discovered or tried to make a model about the atom, which is a solid sphere, just like the Dalton. Dalton said that the atom is a solid sphere. But Thomson add that this solid sphere consists from uniform positive charge, electric charge, and a number of negative charge embedded in it. What's meant by embedded? It means that they are inside it. So negatively charged electrons is embedded to make it neutral. So the number of the positive must equal the number of the negative. This is the postulate of the Thomson model. The number of the positive and the number of the negative are equal. So as I told you, Thomson make this model of atom, which is a solid part, contains positive charge, and this solid sphere or solid part that is contained positive charge has an electron embedded in it, like this shape. Has an electron embedded in it, like this shape. Okay. Then we go to the next science, which is Rutherford. Rutherford make his students Geiger and Marsden perform the famous experiment to discover the protons. So Thomson discovered the electrons, which is formed the cathode ray, and Rutherford discovered the protons, which is carried the positive charge. What is the experiment that Geiger, the students of Rutherford, made? Geiger and Marsden, okay? They bring a piece of metal, as you see here. They bring a piece of metal, as you see here, and this piece of metal painted from inside with a metal sheet with a zinc sulfide. Why? Because this metal sulfide glow when they hit with something. So it gives a kind of fringes or glowing. And they make a box of lead, contains a source of alpha particles. They start and a sheet of gold. This is very thin sheet of gold foil. Start to make the box contains the alpha source to produce or emit this alpha rays. And as you know that the alpha rays has positive charge. It's the nucleus of the helium atom. It contains 2 electrons, so it carries positive charge. They go through the very thin gold foil, and some of them reflect in the blue color. The other pass directly without reflection, and some of them deflect. So we have 3 types of rays. Some of these alpha particles reflect back, and some of them pass directly without reflection, and some of them in the pink color, they deflect. Why? Why do you think? Rutherford think about all of these actions occurs due to occurs for the alpha particles. He said that if the alpha particles pass directly without hitting anything, it means that we have empty space inside the atom, and represent this empty space around the nucleus. We don't have something to obstacle this rays, so they go through directly, or they directly move without obstacles in a straight line, so there is an empty space inside the atom. But if they come and hit and return back in this direction, it means that there is a positive part in the atom, and it's very heavy and dense, make this alpha particles return back or reflect back. And he called this very heavy dense part in the nucleus, it's called the nucleus. He named it the nucleus, and inside this nucleus we have a positive protons that is collide with the alpha particles with a positive charge and make it reflect back. Now, why this deflect? So if the alpha particles pass directly, it means that there is a space inside the atom. If the alpha particles reflect back, it means that they hit a very dense positive part in the center, which is called the nucleus, that contains the positive protons. And if they deflect due to the repulsion, they pass near to the nucleus with a positive charge, and positive with positive will repel. They go through other side, or they deflect in the form of pink line, as you see here. And this is the postulate of Rutherford atomic theory. What is the postulate of Rutherford atomic theory? Rutherford atomic theory, he said that the atom is an extremely small size particle. It's very, very small. We cannot see it with our naked eye. It has a complicated structure. It represents the solar system, as if the nucleus found in the center, it's the sun, and around the nucleus there is electrons rotate around this nucleus like the planets rotate around the sun. And this nucleus, it's very small, it has very dense part, it has big masses in comparison with the electrons, okay? Its mass concentrated in it because it contains the protons. That's why it's positively charged. It's positively charged due to it contains the protons. And there is a space between the nucleus and the electrons, and all the atom, it's not solid. So the first one goes out from the idea that the atom is solid was Rutherford. Dalton said that the atom was a solid. Thomson said that the atom was a solid with positive charge and electrons embedded in it, while Rutherford said it's not solid, it has an empty space, and it resembles the solar system. The sun in the center, and around it the planet rotates. So the nucleus in the center with a positive charge. Around the nucleus, the electrons rotate, make a space between the nucleus and the electrons. And all the mass of the nucleus is negligible, as you know before, because as we learned from the cathode ray, that it consists from smaller particles called the electrons, and it has no mass. It's negative charge with no mass. But we have drawbacks of Rutherford atomic model. What are the drawbacks? He didn't explain. He said that the electrons rotate or revolve around the nucleus as the planet revolves the sun, but he didn't explain why the system appears in this way, how the electrons revolve, is there any energy levels or something like this? They rotate in the same place, why they don't collide together? He didn't give us anything about the way that the electrons revolve around the nucleus. Okay, and this is the first lesson for us. We should solve some question together. Choose the correct answer. Wait. So, choose the correct answer for each of the following sentences. We're going to solve the questions. Who is the scientist who believed that the matter composed of water, dust, air, and fire? Of course, Aristotle. What is the name of the scientist who was the first to define the atom? As it's not divided, comes from the Greek word. He is Democritus. Democritus. Okay. Hypothesized that the compounds are composed of certain elements combined in a simple numerical ratio. The one who defined the element, he is what? Dalton, Schrödinger, Thomson, or Bohr. He is Thomson. Okay. Next. Electric discharge experiment. The cathode tube of Tomtom proved that the atom is solid, contains a vast space, contains a positively charged particles, contain negatively charged electrons. Of course, Thomson experiment proved that the atom contains negatively charged particles. Okay. The cathode rays consist of very fine particles. They are called electrons with a negative charge. Which of the following properties? Wait. Which of the following properties is the strong evidence which prove that the cathode rays exist in all material? They exist in all material. So they have thermal effect? No. They move in a straight line? No. They consist of very fine particles. They don't differ either in behavior or in nature if the material of the cathode is changed. This is the point. Yes, all the cathode rays have, whether the material are similar or are different, so they don't differ in the behavior or the nature. All of them carry negative charge, all of them have thermal effect, all of them move in a straight line, all of them has no masses or the mass is negligible. They carry negative charge, whether the material is same or different. So they don't differ either in the behavior or in the nature if the material of the cathode is changed. Which of the following rays are deflected toward the positive pole when they are affected by the electric field? Of course, they are deflected toward the positive pole because they carry negative. So alpha, as I told you, it carries positive charge. Cathode carry negative charge. Gamma has no charge. X has no charge, so it's a decathode ray. It's a decathode ray. The metal sheet used in Rutherford experiment is lined with a layer of zinc sulfide. What is the symbol of zinc sulfide? It's ZNS. Because as I told you, it's a fluorescent material. It gives bright fringes or flashes when it hits by the alpha particles. So it's ZNS. Because the zinc is divalent, the S is divalent, or sulfide is divalent, so we write it as ZNS. In Rutherford experiment, the deflection of the small fraction of alpha particles shows that the atom contains, if the alpha particles deflect, it means that they go near to other positive part. And this positive part is the nucleus that contains protons. So the protons that carry positive charge deflect a small fraction of the alpha particles. Next, what is the name of the scientist who designed the first model of the atomic structure on an experimental basis? He is Rutherford. He made an experimental basis, the gold foil experiment, okay, to prove that the atom consists from, it's not a solid part. This is the first real, or the first imagination or idea about the atomic structure that represents a very large part of the real structure of the atom, because he said that we have in the central nucleus that is carry positive charge that contains positive protons, and around this nucleus we have a space. The electrons rotate around the nucleus in this space, but he didn't explain how they revolve. Next, the scientist who discovered that the electrons have a negligible mass, the one who discovered these electrons, if it's compared to, so he is Tomtom. The one who discovered that the electron is negligible mass or carry a negligible mass is Tomtom. We will go through the next lesson. Next lesson is about the electron or atomic emission spectrum, the motion of the electrons between the levels. Look, we have what we call emission or the line spectrum. What's meant by this? If you bring a tube and this tube contains a kind of gas or vapor. This kind of gas or vapor under very high temperature, okay, and exposed to low pressure. So if you expose this tube of gas or vapor to a very high temperature or a very low pressure inside a discharge tube, this is called the discharge tube. They emit a kind of radiation. This radiation, they start to emit radiation. This radiation called emission or line spectrum. So the radiation comes from the discharge tube due to the presence of gas or vapor under a very high temperature or under a very low pressure. It's called the line spectrum or emission spectrum. We can detect this radiant light by a device called the spectroscope. So what is the spectroscope? Spectroscope is the device that is used to detect the emission comes from the discharge tubes contain gas or vapor under very high temperature or very low pressure. So they try to imagine what is this rays and why the line spectrum comes from. You know that the electrons, this is the energy levels, and the electrons live in this energy level. When they are excited or get an amount of energy, so they start to leave their ground state level and go to the higher energy level and go to the higher energy level. And then after a while, they return back to their place. When they return back to their place or to the ground state, they emit a kind of radiation. This radiation called the emission, and each atom has a certain line spectrum that is defined by it. It's like the DNA of the atom. So the line spectrum, it's a very special thing for each atom of an element that distinguish the atom of the element and produce a certain color that are separated with a dark area. So if you bring the device like this, it's called the line spectrum of hydrogen atom. It's an experiment. We make the discharge tube that contains hydrogen gas, and we put it under a very high voltage, okay? After a while, we'll get electric spark. You'll get an electric spark inside this tube, and let this spark move through the slit or a hole and goes out from this hole to pass through a prism. And as you know that the prism split, the light comes from the slit into colors, but it produces only the color that is distinguished for the gas here, which is the hydrogen. So if we receive this on a dark screen, it appears as four lines, four colored lines in this way. They are four colored lines separated by dark area. This represents the spectrum of the hydrogen due to the pass of the high voltage in the discharge tube. So Bohr, one of the scientists that studied this atomic spectrum and considered this is the way to solve the atomic structure puzzle, because all the things that comes before, or all the scientists comes before Bohr, just give him a hint or a base to build up his theory about the atomic model. And he make points. He said that we have a very dense part in the center. It's called the nucleus. And this nucleus contains a proton that is carry positive charge in the center. And around the nucleus, we have electrons revolve. We have electrons around the center, around the nucleus. These electrons carry negative charge and revolve around the nucleus. Revolve around the nucleus. Their number equal the number of the positive charge. So the proton must equal the number of the electrons to be the atom to be neutral. In a neutral atom, the number of positive equals the number of negative. Okay? And during the revolution of electrons around the nucleus, there is a kind of centrifugal force arises, which is equivalent to the attraction force. So, kind of centrifugal force make the electrons move away from the nucleus, and the kind of attraction force between the positive and the negative charge, and both of them are equals. That's why the electrons rotate around the nucleus in a very fixed orbitals or limited orbitals. So he make the electrons jump from one level to the other level in a fixed